Alrighty, everybody. So today we're going to look at some of the graphing calculator approaches to doing some of the polynomial work that we were talking about in the first half of chapter 4. So today we're going to look at how do you find zeros of a function, a polynomial, if their algebraic ways just aren't working very well, or if you just want to utilize the graphing calculator sort of technology. So we're definitely going to be using that concept of graphing calculator to help us. So first of all, let's get back to what are zeros. So being able to do that. So zeros of a function are the places where the graph crosses the x-axis if they are real numbers. So if we are looking for real zeros, those would be the x-intercept points on your graph. But if we have functions, polynomials, where the zeros aren't real, just in general, they're the places where those are the x values that we can substitute into the equation, and we get a zero for our answer. So they don't all necessarily have to be real, but a lot of the ones for polynomials we were looking at had some of both, and some just had all real, some all imaginary. Today we're going to focus in on the zeros of the function that are real for polynomials because we're utilizing the graphing calculator technology. So zeros just being the places where, when we put in that value of x, we get a zero answer. So the real ones, those would be x-intercepts. Now, how do we find them? Well, what methods do we use in the first half of chapter 4 that would help us find these x-intercept points? Well, the first way, the easiest way to find these x-intercepts would be to solve by factoring. That's the easiest way that we can go through and find these values is to factor it, break it down. If it works, that's great. Well, what if it doesn't factor? Some other options. If it's degree 2, what's your backup plan? Quadratic formula. All right, our little x equals opposite of b song here. So quadratic formula is great if it's degree 2. What if it's not degree 2 and it doesn't factor? Well, then we had our p over q, basically a glorified guess and check, and then we use synthetic division to help us determine which ones were zeros. So we use synthetic to find if any of them were roots, if we could get a zero. P over q, though, again, that only works for rational roots. Those are nice numbers. That wouldn't help us at all if we had to deal with, say, those roots were square root of 17. Wouldn't help us in the least doing p over q because that only gives us rational roots. So today, to be able to find these x-intercepts, instead of doing these more what I would consider algebraic methods, that's like doing your algebra, what we're going to do today is we're going to do graphing. We're going to do a graphing approach. Now, obviously, if you're going to do that by hand, that's terrible. That'd be an awful way to do it. But we have a graphing calculator, so not so bad. We're going to utilize that technology. Okay, so we're going to back up a little bit then and talk about, graphically speaking, what does a zero mean? It's called the location principle. It's one of these things where I think it's pretty common sense, but it makes sense if you look at the definition. So if you're going to have a zero on a function, an x-intercept, if you're going to cross the x-axis, what that means is the value of your function, the answers for y, have to change sign. They have to go from either negative to positive or positive to negative. So I'm going to show you what I mean with this picture. So we have a parabola, and I'm just going to have you look at this point right here and this point right there. So we have this point A and this point. We plugged in A, plugged in B, got the value of the function, 2 points on the parabola. The value of the function down here, this f of A, is negative. It's below the x-axis, so below meaning negative answer. This f of b is positive, so I'm going to highlight that up in the definition up here, the location principle. So it says suppose f of a is negative and f of b is positive. If you're going to connect those two dots on your parabola, or whatever this graph is, the only way you can do that is if you cross the x-axis somewhere in between. So in this interval between the a value and the b value, somewhere in between there, we're going to have to cross the x-axis. I know that because I started off with a negative number and I ended up with a positive number. The only way to do that is to go through 0, to cross that x-axis. So what we're looking for is a sign change for y. If the value of the function changes sign, we must have a 0 in between. And that would work too if you're talking about going from a positive answer to a negative answer as well. You're going to have a sign change. So if it ever goes either direction, negative to positive, positive to negative, we're going to have a change in sign. So graphically, that's what we're looking for when we're trying to find these. Okay, so here's what I'd like you to do on this next one. I'd like you to go ahead and think about this one as it would have been in the first half of the chapter, solving it algebraically. See if there's a way that we could solve this polynomial and find its zeros. So it's a degree 3, which means it could have 3 real, or 1 real, 2 imaginary. There's 4 terms. So if we look at that, I think we can think about factoring by grouping and see if it works. Is this one a good candidate for grouping? Looks like I can pull out an x squared. I can pull out a minus 2. This one works great. It's a great candidate for that. So we can actually do it the way we were thinking before. We can do it algebraically. So x minus 4, x squared minus 2. What's going to make that 0? Well, the first one would be x equals 4. So we should have a 0 at 4. For the other one, I just need to solve and see what makes x squared minus 2 equal to 0. What kind of solutions are those going to be, real or imaginary? Well, when I solve, it looks like I'm going to get a positive number over there. Square root, square root. Be careful here, plus or minus. Are those nice numbers? No, they're not rational. They're irrational. Plus or minus square root of 2. So P over Q wouldn't have really helped too much with that one. We could have gotten the 4, though, for that value. So I know I can do this one algebraically. I just kind of wanted you to know what numbers you were shooting for before we started. So you could have done the algebraic approach. Could have done P over Q even, because we have that 4, and then we would have gotten down to degree 2. But could you do it with your graphing calculator? So what I'd like you to do is go ahead and get this one typed in. So I'm going to have you go ahead and type that in. Once you have it typed in, go ahead and pause the video for a second. Get it typed in, and then we're going to talk. Okay, so you hopefully have this one graphed in there now. So it looks like our degree 3 should be crossing 3 times. Well, yep, we got 3 real solutions, so that makes sense. And it looks like one of them crossing right at 4, so we have that nice whole number answer. The other two seems reasonable. Square root of 2 is about like 1.4. So 1.4, negative 1.4 seem pretty reasonable for the graph when we look at it. But what I really want you to look at is the table. So can everybody go to your table here? So second graph to your table. Make sure you can see negative 2 all the way up to 4. So I want you to be able to see all of that. So go to your table and make sure you can see that. Let's talk about this location principle again, this idea of sign change, where the value of the sign for y changes is where you're going to have real zeros. So I want you to take a look at the table and see if you can locate where those things are. Right, so starting at the first one, at negative 2, y was negative 12. At negative 1, y was 5. So look at what's happening between those two right there. And if you notice, I did put this right on your note sheet here. So if you want to circle it over there right on your note sheet, because you can have that as a record then. That's the first one I'm looking at. Negative 2, and then to negative 1, the value of y change. So the sign changed there. So what that tells me is there's going to be a real 0 between those two values. So I'm going to go ahead and start writing down what I'm finding here. So there's going to be a real 0 between negative 2 and negative 1. How do I know? Because f of negative 2, the value of the function was negative 12. At f of negative 1, the value was 5. There was a sign change. So that sign change between those, I know then it has to cross the x-axis. Okay, well, where else does that happen? Go back to my table on my graphing calculator here too. Then we can circle it there. Looks like it happens again between 1 and 2. So over here, I'll do the same thing between 1 and 2. Again, there's going to be a real 0 because I know that at f of 1, it was 3. At f of 2, it was negative 4. The only way to go from positive 3 to negative 4 is to cross the x-axis. So there was a sign change there too. All right, last one. We know there's this third 0. This will happen pretty regularly, I guess, with some of the ones we look at anyway. If you look at your table in the graphing calculator, there's actually one that says 0 for y. Awesome. That means it's a 0 of the function. So 1 is occurring right at 4. So we have one right at 4. How do I know? Because f of 4 is equal to 0. It's actually a 0 of the function. So I can find out where they're located. I have a ballpark idea because of the sign change. Or you actually know a 0 because it says 0. All right, well, there's a kind of a way then to actually locate it exactly. So I know approximately where it is now in the graphing calculator. How can we use the graphing calculator to actually find them? Well, here's how you do that. And this is what we're going to be doing for a bunch of these today. If the algebra hadn't worked well, what's our backup plan? Well, we're going to go to second, trace. It's called the calculate menu. We've been here before for max and mins. We're going to do number 2, which is the 0. So we are looking at this one. We want number 2, the 0 of the function. So let's go to number 2. And it's going to ask you those 3 questions like it did before. So left bound, right bound guess, exactly the same thing as when you were doing max and min points. So just get your cursor to the left and press enter. You might need to use the X and Y values at the bottom of the screen to be able to tell where you are. Because sometimes the cursor, it's so steep, you can't even really see it. It goes past where you can even see on your graph. So if you can't see it, use the X and Y values at the bottom to guesstimate. You know between what two numbers it is, so make sure your boundaries, these little triangles that are going on the screen, are boxing in one of those so you can see a 0. And the reason, again, that we have to do this whole question thing, left bound, right bound, guess, is it's possible that there's more than one real solution. And this one there is. So how does the calculator know which one you want unless you give it a boundary to look in? So we did the left bound, the right bound, now the guess, press enter, and it gives us that negative 1.414, which is the same thing as square root of 2. So we get an x value at negative 1.41. Yep, that's our negative square root of 2 that we got before. To get the other one, just go back to second trace, go to number 2, we want our 0, and anywhere to the left of this next one, so it doesn't matter, and then anywhere to the right of it, we're just given the boundaries, and then we're going to do our guess and press enter. And there's our 1.414. Now, if you wanted to get the other one, you could definitely do the same thing. I know it's crossing at 4, though, so I probably wouldn't take the time to do it, but the calculator will give you that as well. I want to show you what happens if you pick something where there isn't a 0. If you give it an interval that does not have a 0 in it. So say I did my left bound here, and then I do my right bound, say there, and then I do my guess. Now, there's not a 0 in between those two places on the graph. It's not crossing the x-axis. Watch what the graphing calculator says. It will tell you error, no sign change. Well, no, the sign didn't change. That means the value of the function didn't go from positive to negative. That means it didn't cross the x-axis. So it's telling you exactly that location principle as your reason. All right, let's go ahead and try one more then. So let's take a look at this last one. It says approximate the real zeros of the function to the nearest tenth. That's plenty. When you look at this function, think about it from our perspective of the first part of the chapter. It's degree 3, 3 real solutions maybe, 1 real, 2 imaginary. Not a great candidate for factoring by grouping, right? Doesn't group. Think about P over Q. Which number's P? P would be the 6, right? That would be the P value. Q is 12. So think about what that list would look like for P over Q. Lots and lots of fractions, right? So it may not even be something you even want to attempt. So if you're not super crazy about P over Q, and remember, P over Q only finds rational solutions. What if they're not real? Or what if they're not rational? P over Q is not going to help you. So let's see if we can use the graphing calculator to help us. So go ahead and pause the video, type in the equation so you can take a peek at your graph. So go ahead and do that. All right, so I have my equation in there. Let's go ahead and go to graph and see if you're seeing the same things that I am on your picture. So it looks like this graph crosses 3 times. We can kind of guesstimate where we think they might be, but I really want you to use your table to be able to see where those are happening so we can double check. So let's go to our table and see if we can figure out between what two integer values are we having zeros. So look for that sign change. Looks like the first one's happening here between -1 and 0. So it looks like I have one between -1 and 0. All right. Next one looks like is happening between 0 and 1. And then our last one, because we have 3 real roots, looks like it's happening between 1 and 2. So they're happening kind of boom, boom, boom here, right in a row. So we have those 3 zeros kind of happening all at the same time. They're coming back and forth, up and down as we go across that graph. So it looks like they're happening in those places. So that's where our signs are changing. So we know that we have a real 0 in between. So I want you to go ahead and do your second trace. Go to number 2, do left bound, right bound, guess, and find those 3 zeros. So go ahead and pause the video, try them, and then we'll check back in and make sure that we came up with the same answers. So left bound, right bound, guess. All right, so we find the zeros. I got -0.5, +0.7, and +1.4. So we have 3 real zeros. Now, when you looked at those values, I rounded them to the nearest tenth. None of those were terminating decimals or repeating decimals. So meaning like the decimal stops or repeats. What that tells me is none of them were rational answers. So if we had done P over Q and we did all those fractions and we did the synthetic division, none of them would have worked. So really good to have this backup plan to find those real zeros. At least it gives us approximations. We have some pretty good estimates of what those real zeros would be. So what I need you to be able to do is find the real zeros, be able to find them on your graphing calculator, left bound, right bound guess. And then the other thing I need you to be able to do is say, where are they located between what two real number answers, integer values, and being able to legitimize that with the sign change. So your reason that it works is because of the sign change. So we have some questions to try. These won't take you too long, but just good to know how to use your graphing calculator to find these x-intercepts.